E flat, A flat, and F sharp. Okay, so what we want to do is we want to put these things in an ascending order. Now there's three possibilities, right? You could start on E flat, you could start on F sharp, or you could start on A flat. So there's three possibilities because there's three pitches in this set. All right, what we want is the version with the smallest outside interval. All right, if we started on E flat, well, that looks like it's the version, right? Because if we start, okay, let me do it this way. So if we start on E flat, then the largest, the outside interval, the interval from the first to last is what interval?
Perfect fourth.
Perfect fourth. And in mathematics, we would call that a 5, right? So the perfect fourth is interval size 5. Okay, so I'll go ahead and do this. So let's just rotate it. Let's just try a different rotation. All right, so if we started on F sharp, and then A flat, and then E flat. So now if we start on F sharp, our outside interval is F sharp to E flat. Whatever that is, it's a lot bigger than a perfect fourth.
It's a 9.
Right? Yeah, it's 9, right? So, and if we started on A flat, it would also be something bigger than a perfect fourth, right?
So in the first option's the best.
The first option was the smallest outside, the most compact form. Okay, so this is called the normal order. So the normal order is the most compact form. Unfortunately, we're not really interested in the normal order. We're interested in the best normal order. All right, so the best normal order is, this is where it gets complicated. We have to, well, first of all, let's put this into numbers before we go any further. And let me find my text tool here. Okay, so the first number is always 0, all right? So what's the interval that F sharp is above E flat?
3.
3. Say it's a minor third, right? It doesn't look like it, but it is. Okay, so this is 3. And then what's, as we said, the outside interval is what?
5 for perfect fourth.
5.
Yes. Everybody follow that?
Yeah.
Okay, so this is 0, 3, 5. All right, and so just to recap, so we found the most compact rotation. First, we put the pitches into ascending order. Then there's 3 possible rotations, and this is the most compact rotation. So this is normal order. Okay, however, as I said, the important thing is not the normal order, it's the best normal order. So that means we have to compare this to what this would be upside down, meaning starting with the A flat and going down. All right, so what I'm going to do here to try to visualize that is, let's start on A flat and go down. This is assuming that we consider left to right as an order, because we kind of read left to right. Okay, now if we start with A flat and go down, okay, A flat is 0. It always starts with 0. Now, going down from A flat to F sharp is what? 2. Very good. Everybody sees why that works?
Yes.
Okay, and then the outside interval's got to be the same, right? Which is what?
Why is it 2?
5.
Because F sharp is really a whole step below A flat, right?
Yes.
It looks like a third, but it's really a whole step. So a whole step is an interval class of 2.
Okay.
Down 2, you're counting half steps. So you go down 2 half steps to get to F sharp. Okay, and the outside interval's got to be the same, which is what?
5.
5.
Yes. Okay, so now we've got 2 versions of this thing. We've got the original, you know, just like in life, there are many times where you have to ask yourself, would this be better upside down? Like when I'm eating a cheeseburger, there's a point like halfway through the cheeseburger where you've got to consider that. You got to consider all the rotations of the cheeseburger, because sometimes you got to rotate it a little bit depending on how things have gone. And then you have to consider inverting it upside down, right? So I think professional cheeseburger eaters always consider the inversion. And that's what we're doing now. We're considering the inversion. Okay, so we had 0, 3, 5, And now the inversion is 0, 2, 5. So we want the one that is most compact. Now here is one of these little funny things. It's not exactly like alphabetical order. In math, we call that lexicographical order. And in certain things in set theory, we use lexicographical order. But in this, actually, we don't. We use a right packing is the word for this. So what that means is how we determine which one is better. Well, they both have the same outside interval, but which is a lower number on the next to outside interval. In other words, 3 is the next to outside number, and 2 is the next. So which one is lower, 2 or 3?
3.
2. 2 is lower than 3. So this is the best normal order. Everybody see that? So
if
let's
they
just
were- sorry.
let's repeat the steps we did again. First we had the series of random pitches. That was our set. All right. Then we put it into an ascending order. Then we compared all the rotations of the ascending order to see which one had the smallest outside interval. And that was this, 0, 3, 5. Once you get that, then you compare that to itself upside down. The upside down version was 0, 2, 5. 0, 2, 5 is preferable in this system to 0, 3, 5 because it's a lower number.